Okay. Hi, everyone. Unfortunately, I don't speak Spanish, so you will have to live with English. Let me share my screen and kick off a very quick 15-minute talk. So here we go. On the bleeding edge of OpenTelemetry. So I'm Philipp. I work for Elastic, the company behind Elasticsearch, Kibana, Beats, Logstash. So observability or monitoring is very close to our heart, and OpenTelemetry is kind of the new standard that everybody is striving for. But before we dive into that standard right away, let me take a step back and see, like, what are we even trying to collect here? What is the relevant information, and why is it important, and how do we collect it normally, or what is everybody doing? So logs are generally the thing that I assume pretty much anybody running in production is using. It's basically a chronological record of events. It's very much on a component level. So your application says, at this point in the application, give me this log output, and then here, give me this other log output. So it's chronological, and it's a record of events. Ideally, it's more event-like, where you have a bit richer structures rather than just a log line. So it might include, like, which user did the request, and from what IP was it coming, and what module were you targeting? So you could slice and dice the data to see more what is coming out of that afterwards. And the Elastic Stack, or ELK Stack, as it was known before, is probably the most widely used tool here. Might look something like this, where I'm looking through my Nginx access logs, and you can see I'm looking at everything that failed. And you can see here some robot failed to access that file because, well, it doesn't exist, and then it got an error. So this is logs. Then you have, and like I said, ideally you go from logs to events where you have a richer structure. And when I mean richer structure, something like this. So for example, I have not just this log message, but you have some additional information. So I know in a structured way which user, which IP address, what URL, what was the event. So I could aggregate on any of these or filter on any of these and kind of like get a much richer information from that. So that's it for logs. Next up, metrics. I assume that most of you are using metrics as well. It's normally a periodic measurement of some numeric KPI. It's like how many users are on your system connected in parallel, and how is that behaving, like maybe some latency, load of the system, whatever. Prometheus is one of the most widely used options or tools there. For example, here you see the Prometheus server that we are scraping into the Elastic Stack, and we can just take that existing data and then visualize it as well. Next up, for example, you might have Uptime, which is also probably used by many, where you have some synthetic or proactive monitoring, maybe something like Pingdom, which is continuously pinging your sites or running through some common steps as a user to see if your site is working, and also it's responding in the time that you want it to. Our take is something like this, and you can see this is always the right domain for any demo, and I'll skip the demo today because we don't have enough time, but otherwise we could see this in action as well. But you could, for example, say from this pinging location, I have pinged my application, and you can see at first it was responding very slowly, and now it's kind of like more or less stable, and one request failed here. Final thing after logs, metrics, health, and the fourth thing is traces, which is probably less widely used than the others. The main difference between tracing and logging is logging, like I said, is very much on that component level, whereas tracing is on the request level, and it's much more about the context. So it's like you request, for example, that login, and rather than just having the line like login failed, you see like this was the request as it came in. These were all the other services that it touched, and you also see like how long did it take to respond to that entire request. So it's not just on the component level, but it's really on the request scope where this is sitting. Zipkin and Jaeger are common tools there. Jaeger normally has a white background, but I think that the pink one with the pink eyes also gives it a very nice touch. Our take is something like this, where you could see, for example, this is where you spend your time, either in the UI rendering or in the backend application. You can see how long the transactions take. So for example, if it's more than a couple of seconds, it's probably not acceptable anymore, and you can see how many requests you're firing against your service in parallel. And then you could dive into the initial or individual requests to see how they are behaving. So Tracing, or application performance monitoring, APM sometimes called, or distributed tracing, is kind of like the new hotness, because you have much more complex systems where you want to get a better overview of what they are doing. And the Wikipedia definition for those is the monitoring and management of performance and availability of software applications, which I will try to explain differently. Previously, when you had the big, good or bad old monolith, it was pretty simple. Like maybe you had a load balancer, you had a database, and you had a monolith, and you had a request coming in, went to the database, and then it went out. And with logs or metrics, you could get a pretty good overview of what was happening and how your system is behaving. Nowadays, most of you probably don't have a monolith anymore, which is much more complex. Like you have a full zoo of services that call various databases. So it's much harder to have an overview of like, how long did the request take? Where did it fail? Where was it slow? Why was it slow? Why did it fail? Like those questions are suddenly much harder to answer than before. And that's where tracing is basically coming in. And this is, of course, also better times for vendors, because suddenly you need much more tooling and more advanced tooling. And OpenTelemetry is kind of playing into that vendor agnostic, but more tooling support. So the goal is generally you have a transaction context, so you have the entire transaction. You can reconstruct the individual requests within that flow, and you can query and visualize all of those transactions. So for example, the main terminologies is you have a trace, that's the record of a request, and it's a directed acyclic graph. So it comes in, and then it can maybe fence out to your various services, and at the end it combines again to give you the final response out. So that's the trace, or the full request. And then you have spans, which are like the individual named and timed operations within that request, that might be nested as well. The way you propagate those is you have a span context. So basically a request gets a ID for the entire request, and then you can recombine all the individual pieces, and you propagate it by having an ID normally in the header. So for example, in HTTP, you would have an HTTP header that you would carry around as that request works its way through all the services. So you always know each single request was part of them. The problem is with these requests that every system and every vendor invented their own headers. So for example, if you use Jaeger, which still uses Uber Trace ID, their unique IDs look like this. If you use the Elastic APM agents, they look like this, and they're totally not compatible. They're kind of similar, but they're not the same. So you cannot use them in combination. And that's where standardization is trying to solve that. And the first one was Open Tracing, which was a vendor neutral API that basically tries to have this header, or the naming and of these APIs consistent, so that different systems could work together with each other. It also has from Open Tracing, they also have this nice graphics to explain the concept again. So let's assume we have two services, service A and service B. All of the white area here is the request. This is the first span that we're calling, and then we have multiple child spans. And then it's also calling the service B with another child span. All of this is the request. And then you can see these individual spans. And which is also nice, you can see that logs in comparison are very much on the component level, like you have a log statement here and a log statement here. But these individual log statements don't give you the full context. What you also want to have in your logs probably is collect or add that trace ID to the logs. So you would know all of those logs came from one single request, so that you can combine those again. And then the header or span context that they are defining is you have a trace ID, a span ID, and then the baggage items is where you can provide whatever custom IDs you want to provide. What is with Open Tracing, the limitation is that it's only headers or APIs. It doesn't have a wire protocol, so it doesn't specify how different systems should work together. It's really only the headers. That's why you cannot just take one Open Tracing solution and combine it with another one, because while they have the same headers, the wire protocol, how they talk to each other, are different, so that won't work. And for that, the W3C trace context was created, which basically allows you to pass trace context information across systems. So it's trying to fill that gap that it's not just an API spec. So this will be passed on and other systems will support that. But the current hotness is in OpenTelemetry, which comes out of CNCF. It covers not only traces, but also metrics and logs, or is in the process of that. And it replaces or supersedes open tracing and open census. So what it does is it tries to unify all of those things that you try to collect from an observability point of view. And it's vendor neutral, but has wide vendor support. So lots of vendors, Elastic and many others, are part of that and try to integrate into those agents. And you basically have one generic agent per programming language then, and it can talk to various backends so that the agent or the instrumentation is the same, and you could just switch out the backend if you want to. But what the advantage is, you don't have to or change any instrumentation on your application side. You can just switch out the backend. Let me switch over that because we don't have enough time. To integrate into OpenTelemetry, a vendor can integrate in one of three possible ways, and the vendor can do 1, 2, or all three of them. So what you can do is you have a generic agent, which is the open tracing, OpenTelemetry agent for the various programming languages, and then you have a vendor exporter on that agent. So for each agent, the vendor will need to provide an exporter, and then it can talk to whatever backend the vendor is providing. So this might be Elasticsearch here and the Elastic APM server here that takes that. So we would need a vendor exporter, which we don't have, but other solutions have those. It's more work because for each agent, you will need to have that exporter in that programming language. The next thing is there is the OpenTelemetry collector. So here you have an agent and the OTel protocol talking to the collector, and only in the collector, so only in one piece of software, you need a vendor-specific exporter that talks to your application or to your specific backend. And the alternative is that your backend implements the OpenTelemetry protocol directly, then you don't need the OpenTelemetry collector anymore. Then the agents can talk to your solution directly. It's kind of a trade-off between like how many integrations do you want to do and how deep do you want them to be. For you as an application developer, the nice thing is you need only that agent and can then switch out the backend from different vendors. I don't want to say at runtime, but very easily without re-instrumenting all your applications. And then, for example, here you can see we are using the OpenTelemetry Java agent here in a slightly older version still, and that was able to send that through the Elastic APM server into Kibana to show you what is in there. Or it, for example, sees we have used the OpenTelemetry Java agents, and then you see the different services that I'm running here and could then show how they're behaving. Or you would see the transactions and the requests and all of that. And with that, we're almost out of time. Let me switch to my conclusion slides. I'll skip over a couple of them because I want to stay in time. So what is relevant? Distributed tracing is, especially if you have something more like a microservice architecture or distributed architecture, you want to have that. And I hope it makes sense why you want it and why logs, for example, might not be enough anymore because it's too much component level and not the overall request level. OpenTelemetry is getting very popular, and various vendors, including us, support that. And it allows you to keep your instrumentation the same and only change to the right backend. So the backends can kind of like fight on storing and visualizing the data better than others, rather than having to fight on the instrumentation. And all of that is available for free for you to use. So you can go pretty wild on OpenTelemetry already. So that's it for me. Thanks a lot for joining, and enjoy the rest of the day and the other sessions. Bye.